This is a demonstration video for the Osmowsis group project for group A7-45 for the CS6310 Software Architecture and Design class in the fall of 2019. So to begin with, I want to take a look at some of the improvements we've made at customer request. Firstly, the customer requested the addition of a more dynamic obstacle, a dynamic type of obstacle if you want to think of it as an obstacle. We've added a gopher, which is an active adversary that's going to be moving around and hunting the mowers. And we've implemented that in the gopher class that embodies most of that. And then we've made two changes, significant changes to the mower class. First, we added an L-scan capability. Initially, the mowers only had a C-scan. The customer requested that we add an L-scan capability, so we've done that. Additionally, the customer also requested that we have the mowers have the ability, they need to track their energy usage. They have batteries and they have limited energy. And in addition to that, they have to have a charging pad. So all the mowers in the simulation are going to start on their charging pad. And if the mower happens to visit a charging pad during the simulation, they charges up their battery and they're able to continue at full power. So we've addressed those changes mostly in the mower class and a few other places. Finally, there was a request, since the specification changed from just 1 or 2 mowers to potentially 8 mowers, there needs to be some cooperation and some communication between them. So we've added a mower strategy interface and the mower strategy message queue to basically allow you to provide some communication between the mowers to coordinate. And specifically, kind of as a demonstration, we've put together a smart mower strategy that makes use of some of those facilities to kind of show you how this would work when you're implementing your own strategy. So as the customer's developing their strategies, they can kind of look at that as a starting pattern and expand from there. So let's go ahead and move over and look at our application. So what you're going to need to do, I'm starting this on our demonstration Linux virtual machine. I'm going to go ahead and start a terminal window. I'm going to go to the desktop directory, then Osmowsis directory. If we get a listing of the files that are here, we have our jar file, and then we have some scenarios. And I'm going to be using the Smart 6 scenario. So just to kind of talk through some of what they're doing, I think it'll demonstrate it best. So let's go ahead, and you're going to do java-jar, and you're going to do /, and you got to put your Osmowsis jar. And one thing too with Linux, you have to have the / or it's not going to like it. So you have to do java-jar /osmosis.jar, and then finally we have to name the file name of our scenario, and we're going to go with the Smart 6. It's one of the larger ones, lots of mowers and a fairly large grid. So we start our application. One thing that you'll notice right away is it's pretty clear, that you can't see the whole grid on the screen, but we have scroll bars, so you can scroll down through, as you're following along with it, and you can scroll both directions. So we'll stop here. This is mower 0 and gopher 0. So just kind of go through here. Obviously the gophers, they have their identifiers, so you can see each gopher is going to have its identifier. And the same with the mowers. Each mower is going to have its identifier displayed on the screen. We also have a battery level indicator, so to show kind of how much power the mowers have. We have an arrow that indicates what direction they're currently set to. And finally, we have an indicator for a charging station. So this indicates that this particular square, the charging station, resides on it. So what we're going to do, if we look up here, in this panel you're going to see as we step through, let each device take its action, or as we step through, you'll see it displayed up here. And we'll go ahead, and we also have a nice little summary down here. So this step through, we'll let the first mower, mower 0, is going to take its action, and it's doing a C-scan. And let's do a couple other mowers. And they're all going to be doing C-scans. And this is, again, this is just the smart protocol that they're using for this particular example. And then you'll notice the mowers are starting to steer, as we go through here. And then finally they're going to move. And you'll notice we have the battery. There's our charging station. We've moved away from it. And if you look, as we've moved away, the battery levels went down from 75 to 71. So the power level is dropping. And finally, if we don't want to step through each mower's actions, if we want to just skip to the end, we can fast forward, and you'll get a message that your simulation is complete. And down below it will have you a summary of the size of the lawn and the grass that was cut, the grass remaining, and the number of turns that have been taken. We'll close the message. One other thing I wanted to point out is we stepped through actions, we jumped right to the end of the simulation. We also have a stop button here so that we're able to stop. And as you can see, like one of the example of the action, we had kind of the output here indicating what action the gopher took. And as we step through, you could see each of those displayed there. And you can see we have the empty square, there's no grass in them, and there's grass here. And that kind of, we also have our fence icon that shows kind of where the border fence is. Now, one other item I wanted to show you as I close the application here. In the directory, there's an output log that's created. And the output log is going to have a list of the entire summary of all the commands, plus that end summary. So it also logs that as well for you to reference. And so that kind of shows off and highlights some of the things we've done here. We've tried to design this so that as the customer's developing their algorithms for the mowers, that they have a good solid base to start on and build their solutions with. And the GUI provides a nice simulation, as far as showing everything, tracking everything correctly. And we just wanted to thank you for taking time to look at our demonstration, and we hope you're satisfied with our product. Thank you very much.